ओके, तो ये जो वीडियो है वो बेसिकली डिजाइन किया गया है टू नो अबाउट द कोफैक्टर, कोएंजाइम एंड प्रोस्थेटिक ग्रुप, व्हिच इज वेरी बेसिक टर्म ऑफ एंजाइमोलॉजी. सो if you have to know about the cofactor, coenzyme and prosthetic group, the first thing is you have to know what is enzyme and its characteristics. What is enzyme? Enzyme is a substance that is made up of protein with a non-protein part, and this non-protein part is generally known as cofactor, coenzyme and prosthetic group. Okay, let me talk about later. So enzyme is a substance that is made up of protein and with a non-protein part, which function is mainly to regulate the rate of biochemical reaction. And as it is regulate the rate of biochemical reaction, that's why the enzyme is also known as the biocatalyst. You will find this term many times in different books, that enzyme is a biocatalyst. So why it's known as the biocatalyst? Enzyme is a biocatalyst just because it's regulate the rate of biochemical reaction. That's why enzyme is known as biocatalyst. It's this important characteristics that enzyme is a biocatalyst. And one thing you have to remember, that enzyme is always secreted by a living cell, but it can be active both inside or outside the cell. Whether it's synthesized by the living cell, but it can be activated both inside or outside the cell. So this is what about enzyme. And obviously the enzyme will bind with a substrate, and this formation of enzyme substrate is known as the enzyme substrate complex, and from this enzyme substrate complex they will create some product which is known as the product of enzyme. So let me discuss it about here. Let's suppose this is our enzyme, and this is, if you guys remember, I've said that enzyme is made up of with a protein part with a non-protein part, but in this structure I basically discuss the protein part of this enzyme. Suppose this is an enzyme which have not any non-protein part, but it's constituted with a protein part, and this protein part of this enzyme is known as the apoenzyme. This is the apoenzyme, and we know that every enzyme have a binding site through which they will bind with the particular substrate, and they will form the enzyme substrate complex, and they will create some products from this enzyme substrate complex. So this site is known as the active site, and as the substrate will come and bind with this site, that's why the active site is also known as the substrate binding site. This is what about the active site of this enzyme. The active site of this enzyme is also known as the substrate binding site, as the substrate will come and bind with this site. That's why it is known as substrate binding site. So this is what about enzyme. What is the apoenzyme? The protein part of this enzyme is known as the apoenzyme. All this portion is made up of protein. This protein part is known as apoenzyme. Let's suppose this is our substrate which will bind with this enzyme at its active site. This is a substrate. Now the substrate will get attached with the particular enzyme, and they will form a complex like structure, and this complex like structure is known as the enzyme substrate complex. Enzyme substrate complex. Now from this enzyme substrate complex, after some time we will find our product. This is our product which we will gain from this substrate or from this substrate. Both are similar. This is the part of our apoenzyme, and this substrate which was previously attached to this enzyme, now it become into some product. So what we learn from this diagram? We learn that every enzyme is constituted with a protein part and also a non-protein part. Anyway, this enzyme is consist only with the protein part, and the protein part of this enzyme is always known as the apoenzyme. And every enzyme have an active site, which is also known as the substrate binding site, just because the substrate will come and bind over this site of this apoenzyme. This is whatever the substrate binding site and apoenzyme. Now, once the substrate come and bind with the active site of the substrate binding site, they will form a complex-like structure, and this complex-like structure is known as the enzyme-substrate complex. And after this formation of this complex structure, the enzymatic reaction will go up, and ultimately the substrate will convert into some specific product, which is known as the product of enzyme. And the enzyme, and now what we notice here that this is the first time when this is the structure before the reaction. That means before the reaction the structure of this enzyme like this, and during the reaction the structure of this enzyme like this. Both the structure are similar, and after the reaction also the structure of the enzyme remains unchanged. So what will happen? Whatever may be the reaction, whatever may be the enzyme substrate complex, whatever may be the product, the enzyme, the structural configuration of enzyme will always remains unchanged. This is one of the most important characteristics of our enzyme. And also every enzyme is very much specific for their substrate. Means one enzyme can bind with only some specific substrate, and this characteristics of this enzyme is known as the enzyme specificity, which I will discuss in my upcoming video. So this is what about the enzyme and its active site, and what is apoenzyme, and what is the enzyme substrate complex, and what is the product of enzyme. So let me wipe out it. Now I will discuss the parts of enzyme. If you guys remember, I've said that enzyme is consist with a protein part and also a non-protein part. Protein part and also a non-protein part. Non-protein part. This non-protein part also known as the conjugative protein part. Conjugative protein. This is what about the protein part and the non-protein part. So let me classify it. This is what about the parts of enzyme, not the enzyme classification. Parts of enzyme. This is made up of protein part, protein part, and this is what is made up of non-protein part of the conjugative protein part. Non-protein part. If you guys remember, I've said just before few minutes that the protein part of this enzyme is known as the apoenzyme. The protein part is known as the apoenzyme. It's very much general for each and every enzyme, whether it is consists with the only protein part or whether it is consists with the protein part along with the non-protein part. So this part is very much general for each and every enzyme. So this is what about the protein part. Now non-protein part, we can classify it into two portions. One is in the respect of inorganic part, and with the respect of organic part. Now we can further divide this organic part into two types, and this type is known as this type the coenzyme, and the other part which is known as the another part which is known as the prosthetic group, which you have to discuss now. The organic part is known as the prosthetic group, and the inorganic part is mainly consist with the metallic ion. That means it may be the CO plus 2, Ca plus 2, and there are many examples of this metallic ion. And this inorganic part mainly called as the cofactor. Cofactor may be constituted with some organic part, but mainly the inorganic part is constituted the cofactor. Sorry, cofactor is constituted the inorganic materials. So this is whatever the parts of enzyme. Constitute the protein part, which is known as enzyme, and constitute the non-protein part, which you can divide into two types. One is the inorganic part, and one is the organic part. We can further divide this organic part into two types. One is the coenzyme, and the other one is the prosthetic group. And now inorganic part is maybe the metallic ion like CO2 plus and calcium. This is one of the most important ion present in our body, and also this all these inorganic parts and the metallic parts is known as the cofactor. Now let me explain what is the coenzyme. What is coenzyme? Let's suppose this is an enzyme. This is an enzyme, and this is the protein part of an enzyme. We know the protein part of the enzyme is known as the apoenzyme. The apoenzyme, and this part is known as the active site, where the substrate will come and bind over here. So what is this part? If you guys remember, I've said that every enzyme is some of the enzyme is consist with a protein part along with a non-protein part. This is the part where the non-protein molecules or the particles will come and bind over here. So this site is known as the cofactor binding site. Cofactor binding site, or maybe the coenzyme binding site, or maybe the prosthetic group binding site. In many books you will find that this site is also known as the allosteric site. Allosteric site. I will discuss it later in my upcoming video, so stay tuned. Okay, so basically we'll consider this site for this enzyme, that this is the cofactor binding site, or maybe the coenzyme binding site, or maybe the prosthetic group binding site. Now for this enzyme, basically this binding site, I will consider that this binding site is the coenzyme binding site, not the cofactor binding site, not the prosthetic group binding site. This is the coenzyme binding site. So this is coenzyme binding site. Binding site. And suppose this is our product. Sorry, this is not our product, this is our substrate to which the enzyme will come and bind. But if you notice it very carefully, then you will find the structural configuration. The structural configuration of the active site of this apoenzyme is not as well as same the structural configuration of this substrate. There are difference in their structural composition. So if the structural composition is not same, the substrate will not come to the enzyme and will not form the enzyme substrate complex. So what we have to do, we have to bind a coenzyme. We have to bind a coenzyme. Suppose this is our coenzyme, which we have to bind with this enzyme over a coenzyme binding site. As soon as the coenzyme will come and bind with the coenzyme binding site, the structure of this active site will get changed and it will form a new structure which is similar with the structure of this substrate. Now it will form like this, and this structure is quite similar with the structure of this substrate. Now the substrate can come and easily bind with this active site. Now what will happen? The structure of this active site become changed. Let's suppose the structure is like that. It's become round, and the substrate will bind easily with this active site of the enzyme, and they will form the enzyme substrate complex. But you must add the coenzyme, because without this enzyme the structure of active site will never change. So here this is the coenzyme, this is the enzyme, this is the apoenzyme, and after binding the coenzyme the structural configuration of active site gets changed and it will form the structure like the substrate, and after then the substrate will come and bind with this active site and they will form the enzyme substrate complex, and after the enzymatic reaction we will find our product. Let's suppose this is our product which we will find after the enzymatic reaction is done. Now what we see after the enzymatic reaction, the structure of active site also same as it was in the second position. This is the first position, this is second position, and this is the third position. This is the third position. In case of first position, first A, first B. In case of first position, when it was in the A situation, at that time the structural configuration of the active site was like that, But when it comes to the B position, at that time the coenzyme will bind with the coenzyme binding site of this apoenzyme, and the structural configuration will change into like that, which is quite similar to the structure of this substrate. And in the second position, the substrate has come and bind with this active site and they will form the enzyme substrate complex. At that time also the substrate is attached with this enzyme. But in case of third position, the substrate get converted into some specific product. Now the substrate is not attached with this active site. Still, the structure of this active site of this apoenzyme will not able to back to its first A position. So why? Because at that time also the apoenzyme is attached with the coenzyme remains attached with the coenzyme binding site. But after few moments, the coenzyme will get dissociated from this apoenzyme, and as soon as the coenzyme will release from this coenzyme binding site, the structural configuration of active site of this apoenzyme back to its first A position. When it was this is the structure like the previous structure. So it will changes the structural position of active site when the coenzyme get dissociated with the coenzyme from the coenzyme binding site. So now this is the ultimate position of this enzyme. That means it back to its normal position. This is the position. This is what about the coenzyme. So what will inform this topic? The coenzyme, which is, now you have to remember one thing. Don't. This stands for dialyzable. O stand for organic. N stand for non-protein, and T stand for thermostable. So why this is necessary? Don't. This is the formula to recollect the definition of coenzyme and prosthetic group. The coenzyme and prosthetic group, the dialyzable, organic, non-protein, thermostable molecule. They are the dialyzable, organic, non-protein and thermostable molecule, the coenzyme and prosthetic group. When such type of dialyzable, organic, non-protein and thermostable molecule will bind with the apoenzyme by forming a non-covalent or a covalent bond to increase the rate to increase the rate of reaction, to increase the rate of a biochemical reaction by changing the attraction between enzyme and substrate. Now it may be by changing the structural configuration of active site of this enzyme, or maybe some different procedure when they will accelerate the reaction, enzyme substrate reaction, and after getting the product, when they will dissociate it from the enzyme and the enzyme active site become its normal position. At that time it's known as the coenzyme and prosthetic group. Now if the coenzyme or the non-protein organic dialysable and thermostable part will bind with the apoenzyme by forming a non-covalent bond. What is non-covalent bond? Non-covalent bond is an unstable bond and covalent bond is a stable bond. So in case of coenzyme, they will bind with the coenzyme binding site of this apoenzyme by forming a non-covalent bond which is unstable. And after the reaction, when we will get our product, the non-covalent bond will break down and the coenzyme will get dissociated from this apoenzyme. And after the dissociation of this coenzyme, the active site becomes changed and it will back to its normal position. This is what about coenzyme. But in case of prosthetic group, it is dialysable, it is organic, it is non-protein, it is thermostable. What was the difference? The difference is that in case of prosthetic group, they will bind into the prosthetic group binding site, and the bond which will create between the prosthetic group and between the apoenzyme is the covalent bond. That means which is more than stable than the non-covalent bond. So prosthetic group will bind with the apoenzyme into their binding site by making a covalent bond. That's why as they make the covalent bond, they will not get detached from the apoenzyme after getting the product also. But in case of coenzyme, the coenzyme will get detached from this apoenzyme after getting the product. But in case of prosthetic group, they will not detach. So this is the basic difference between the coenzyme and prosthetic group, and also I have also discussed what is the cofactor. Now let me show an example of coenzyme. Show an example of coenzyme. Folic acid. Everybody knows this term, the folic acid. Folic acid. Now let me draw the structural configuration of folic acid. So more clear to you. So this is what is the structural configuration. The double bond, single bond, double bond, single bond, double bond, and double bond, single bond, double bond, double bond. This is the OH, like the N, H2, and here we will also bind N. This is the structure of the R group. Yes, this is the structure of folic acid. Now the conversion of folic acid to 7,8-dehydrofoliate. The convert folic acid to 7,8-dehydrofoliate. Now let me draw over here the 7,8-dehydrofoliate, which is quite same with the structure of this. One single bond, and this is the OH, and here we will attach another hydrogen group, and there will be a double bond. 1, 2, 3, 4. Yes, this is known as this is folic acid, and this is 7,8-dihydrofoliate. The conversion of folic acid to 7-8-dehydrofoliate is done by folate reductase. Folate reductase. In this case, the NADPH H plus is converted into NADPH plus 3 plus. This is the example of cofactor. This is one kind of example. And if you see that the 7-8-dehydrofolic acid to 5,6,7,8 tetrafoliate, 7-8-dehydrofoliate to 5,6,7,8 tetrafoliate, then we will find that this is the diagram. NH, and will form also the NH as this tetrahydro. So this is what about the diagram. Okay, and there one is two. Okay, so this is what about the structure of 5, 6, 7, 8 tetrahydrofoliate. If you see also the conversion from 7-8-dehydrofoliate to 5,6,7,8 tetrahydrofoliate, you will find that there also happen the same things. That means NADPH plus H plus is converted into